Hello friends, I am Jayraj Rathod, welcoming you in the solution session of example 4.2. In this question, we have two vectors A and B and angle between them is theta. And we are going to prove three important formulas of vectors. And here they are. The first formula is called cosine rule, which is used to find magnitude of resultant vector R. The second formula is known as sine rule. Lami's theorem. It is the relation between alpha, beta and theta. And the third formula is known as tan formula. Normally, it is used for finding the direction of resultant vector. So one by one, let's try to prove these formulas. Let's begin from the cosine formula. So, first of all, let's get our vectors. Let's say this is our required vector A, and now our another vector B. Both vectors should be connected from the tail. So we can say this is our angle between two vectors A and B. Now to find the resultant vector, we have to complete the parallelogram. So let's get the first parallel line, and this will be your second parallel line. So here we get our parallelogram OPSQ. So we can say the diagonal OS will be our resultant vector R. Now, before we start the proof, we are going to need the components of B. So let's consider right angle triangle PNS. Now here OQ and SP are the parallel lines. So we can say our angle SPN is theta angle. So we can say in triangle PNS, sine theta will be opposite edge, or we can say SN upon hypotenuse, or we can say SP. So we will get our SN as a SP sine theta. But we know our edge SP is equal to B. So here we'll get SN is equal to B sine theta. Similarly, let's find out cos theta, which is adjacent, or we can say PN upon hypotenuse, which is SP. So here we'll get PN is equal to SP cos theta, or we can say B cos theta. So we get as a B sine theta and PN as a B cos theta. Now we are ready to find out resultant vector. Let's consider right angle triangle ONS, where its edges are OS, which is equal to our resultant vector R, then ON, which is combination of OP plus PN, or we can say your OP is A plus your PN, or we can say B cos theta, and the third edge is SN, which is B sine theta. Now Pythagoras theorem, which says hypotenuse square is equal to summation of squares of rest of the sides. So we can say OS square is equal to ON square plus SN square. Now let's substitute the values. Your OS is simply R, so here we'll get R square. Now in first term of the right hand side, we have ON, which is equal to A plus B cos theta. So we have to write down square of A plus B cos theta plus your SN is simply B sine theta. So here we'll get B sine theta whole square. Now let's simplify. Our first term is actually a plus b the whole square, which can be expanded as a square plus 2ab plus b square. So here we'll get a square plus 2 times ab cos theta plus the square of b cos theta, or we can say b square cos square theta, plus the square of b sin theta will be b square sin square theta. Now, in further simplification, your first two terms will be as it is, and we can take b square common from the rest of the two terms. So we will get cos square theta plus sin square theta, which will become 1. So, and still the first two terms will be remain as it is. So here we'll get r square is equal to a square plus 2ab plus b square, or we can say r, which is your resultant vector, is equal to under root of a square plus b square plus 2ab cos theta. This is your required first equation, which is also known as cosine rule. Now, let's consider resultant vector make an angle of alpha with first vector A and beta with another vector B. Now, let's try to get relation between alpha, beta and theta, which is known as sine rule. As suggested in name, we have to find the sine of different angles. Here, we already get the value of sine theta, and we don't need this cos theta, so let's remove it. Now, let's try to get sine alpha, and for that, we are going to use right angle triangle ONS, and it is clear that your R is hypotenuse. Let's find out sine alpha is equal to opposite edge, or we can say SN upon hypotenuse, which is OS. So we can say our SN is simply OS into sine alpha, or we can say your OS is R, so it will become R sine alpha. Now let's compare the value of Sn from equation number 1 and equation number 2. So we can say your Sn, which is equal to b sine theta and also equal to r sine alpha. So here we'll get b upon sine alpha is equal to r upon sine theta. Let's call it equation number 3. Now we need to get the value of sine beta, and our angle beta is angle QOS, or we can say our angle OSP is also beta. Now, to find sine beta, we have to create right angle triangle. So let's draw a perpendicular from the P point to OS. So we can say in right angle triangle SMP, we have PS as a hypotenuse. So we can easily find out sine beta equal to opposite to the beta, or we can say PM upon hypotenuse, or SP. So we will get PM is equal to SP into sine beta, or we can substitute the value of SP, which is B. So here we'll get B sine beta. Let's call it equation number 4. Now, let's try to get the value of sine alpha again. But this time, we are going to use the right angle triangle OMP, where OP is your hypotenuse. So, we can say sine alpha, which is equal to opposite edge to the alpha, or we can say PM upon hypotenuse, which is OP. So, here we'll get PM is equal to OP sine alpha. But we know our OP is our A. So here we'll get PM is equal to A sine alpha. Let's call it equation number 5. Now, by comparing equation number 4 and 5, we can say PM is equal to B sine beta as well as A sine alpha. So we can say B sine beta is also equal to A sine alpha. So here we'll get B upon sine alpha is equal to A upon sine beta. Let's call it equation number 6. Now, we already know from equation number 3, our B upon sine alpha is equal to R upon sine theta, and B sine alpha is also equal to A sine beta. So here we get A upon sine beta is equal to B upon sine alpha is equal to R upon sine theta, which is also known as sine rule, which is your second required equation. Now it's time for the third and last equation, the tan rule. And to obtain the formula of tan rule, we are going to use the right angle triangle ONS, and we are going to find tan alpha, which is equal to opposite edge, or we can say SN upon adjacent, or we can say ON. Now we just have to substitute the values. The value of SN is B sine theta upon the value of ON is simply A plus B cos theta. So here we get tan alpha is equal to B sine theta upon A plus B cos theta, which is your third and last formula, which is also known as tan formula. So here we complete our question and we get 3 important formulas: tan formula, sine formula, and cos formula. Hopefully you enjoy the video. If you have any doubt, feel free to contact me.